Many students learn trigonometric ratios primarily by memorizing formulas without experiencing their practical applications. In this project, I utilize a homemade clinometer and simple measuring tools to determine the heights of real objects such as trees and walls within the school area. This approach aimed to make the study of trigonometry more practical, engaging, and easier to comprehend. But before that,
Assalamualaikum and good morning teachers and friends. My name is Misha Nuhumaira binti Muhammad Maruf from Sekolah Menengah Sains Sembrong, here to present my topic about trigonometric ratios.
for now, we'll continue with our slides. So, this project aims to understand what sine, cosine, and tangent are. Then, I'll explain how to make and use a clinometer. Lastly, this project hopes to make learning trigonometric ratios more interactive and practical. Now, let's start with the basics of trigonometric ratios. Usually, these equations are used to find unknown measure of sides or angles in 90-angle triangles. First, imagine a triangle with a 90 degrees corner. Now this is a theta. These are used to represent the values of angles. Now let's learn about the sides. The adjacent is the side next to the angle. The opposite is the side across from the angle. And lastly, the hypotenuse is the diagonal side and across from the 90 degrees corner. So here are the formulas that were used in the trigonometric ratios: sine, cosine, and tangent. Now we've reached the part of the video where we have to make a homemade clinometer. First, you'll need a protector, a straw, a thread, and an eraser, and simple tools like scissors and tape. After cutting the straw into half, we have to tape it onto the protector. Remember, place the tape on the end of the straw on both sides of the protector. Now we'll have something like this. When placing the tape, make sure there is a gap and it is sturdy so we can insert the thread in between the straw and the protector. After that, tie the end of the thread onto the straw while the other end will be tied to the eraser. Now we have our clinometer ready. Let's go test it on a real object. Stand a known distance from the object, hold the clinometer at your eye level and point the end of the straw to the top of the object. When holding the clinometer level, the thread falls on the 90-degree mark. This will represent the 0-degree angle of elevation. As we tilt the clinometer level upwards, the thread shifts. The angle of elevation is the difference between where the thread falls and the 90-degree mark. As you can see in the video, the thread falls on the 45-degree angle. So how do we measure the value? Well, the angle of elevation is the difference between where the thread falls and the 90-degree angle. I've accidentally made a mistake by holding the clinometer backwards. But the rule still applies. So the thread had fallen on the 135 mark, so we'll have to minus it with 90 where we get a 45-degree mark. So here's what we know so far. The distance between us and the object is 2.3 meters. The angle of elevation is 45 degrees. Now for our height, which is 1.5 meters. So the height of the tree will be represented by x. So what formula are we supposed to use? Well, we are given the angle, the adjacent side, and we're trying to find the opposite side. So obviously, we have to use the tangent formula because the tangent formula uses the opposite and the adjacent side. Now let's put in the values. Because we're only trying to find the opposite side, we'll have to place in 2.3 on the other side of the equation. So we'll have to change it into a multiply situation. Since tan 45 degrees equals to 1 multiplied by 2.3 will still stay the same. So in conclusion, the tree height from our level is 2.3 meters. But we're still not done. We still have to add it with my height. 3 plus 1.45 equals to 3.75. Overall, the tree height will be 3.75 meters.
In conclusion, this project helped us see that trigonometric is not just about memorizing formulas. It It can also be applied in real life. From making a clinometer to measure real-life objects such as trees and walls, we had turned mathematics more fun and practical. It also helped us learn the meaning behind sine, cosine, and tangent formulas that we have learned in our Form 3 textbook. I hope through this project, more students will be encouraged to learn mathematics in a more hands-on and meaningful way. So, the reference that I've used to make this video is YouTube, Teacher's Note, and our trusty Form 3 KSSM Mathematics textbook. That's all from me. Thank you for watching.